And then I'm going to go over those two with them. Thank you. Yeah, we're going to talk through. Thank you. All right, so there are 8 possibilities when you have 3 kids. I'm going to zoom in a little. So she used M for male, F for female. So you could have 3 boys, 3 male children, 2 males and then a female, 1 male, then a female, then 1 male, or a female and then 2 males, all female, 2 females followed by a boy, female, boy, female, or the boy and then 2 girls. So there are 8 different possibilities. X is defined as the number of boys. So what are the possible values for X? You could have 0 boys, 1 boy, 2 boys, or 3 boys. So she put 0, 1, 2, and 3 in the table where it says the values of X. So the probability we have 0 boys is 1 out of 8, because that's the only way you can have 0 boys or all girls. Having 1 boy, would be those 3. You have 2 girls and 1 boy, so there's 3 out of 8 for having 1 boy. For having 2 boys, that'd be these 3. So there's 3 out of 8 for having 2 boys. And then 3 boys is 1 out of 8, where you have male, male, male. So what is the probability of having exactly 2 boys? 3 out of 8. That one's nice and simple. We just take the value from the table. What's the probability of having at least 1 boy? 7 out of 8, because 1 boy is right here. This also has at least 1 boy, and so does this. Or you could think about it as the probability of not having a boy, doing the complement of that, so we get 7/8. We are starting a new unit. I wasn't prepared, as I should have been, before I left for break. As you guys know, I wasn't here the last day of school before break because I had a sick kid. And then we had a leak in our kitchen. So that Friday grading day, I wasn't here either because I had to be at home to deal with the plumber. So I didn't get my copies made before I left for break. So I don't have the outline made yet. I'll have it for you guys on Wednesday when I see you. I am going to put it up really quick on the board just so that you can see it. I just didn't have time this morning to make copies. So this unit is on, that's good. On random variables tonight, you just have 5 problems, which it is listed in your packet, which 5 I want you to do. But just so you know, you only have 5 of them to do. And then your test is going to be January 25th. This quarter does end before the 25th. The last day is the 20th. There was no way I was going to make it fit, so this test will be right at the beginning of 3rd quarter. Here's the actual quarter calendar. So we're here. I see you once that last week of the quarter. We have a work day there. I'll see you once that last week. Then going into 3rd quarter, we'll start with review and then we will test. Okay. I don't know what happened to me. I fell apart during this break, I guess. I took your Unit 5 tests home to grade, did them, and then didn't bring them back to enter them today. I'm probably going to run home and grab them because I don't live too far away, so hopefully they should be entered by this afternoon. But I did oh no, things just weren't working for me before break. So, once your Unit 5 test score is entered though, in theory, that's what your grade is for this quarter. Unless you're unhappy with something, then you can figure out what you need to fix, okay? Because this test, the Unit 6 test, will be after quarter 3 begins. So once I put that Unit 5 in there, you will kind of see what your grade is, which honestly is kind of nice. Then you have about 2 weeks before I actually have to give out report cards to fix anything you want to fix. Any questions before we get into today's lesson? No? All right. So we're going to be talking about, down at the bottom, I have our learning targets. We're going to be looking at mean and standard deviation for discrete variables. We're going to talk about what a discrete variable is and what a continuous variable is. And I don't know why. I think because we just love to do this in math. We change the word mean to expected value for this unit. So if I ask you to find the expected value, it's really just finding the mean. If I ask you to find the mean, I'm asking you to find the expected value. They're used interchangeably, this unit. So, first we're going to do some definitions. So, discrete random variables. A variable that takes numerical values that describe the outcomes of some chance process is called a random variable. A table that summarizes the possible values and their probabilities is called a probability distribution. So what Amelia did on the warm-up was she gave us the probability distribution for having 3 kids and looking at the number of boys. In the probability distribution, the probabilities live between 0 and 1. And the sum of all the probabilities is equal to 1. If those things are true, the distribution is called legitimate. So there are 2 types of variables we're going to focus on. One is discrete and the other is continuous. So a random variable that has a countable number of outcomes with gaps is called a discrete random variable. The key part there is with gaps. So that was like on the warm-up, the number of kids. You can't have 2.5 kids. You have gaps between the numbers 2 and 3. So it's discrete. Another way to think about it is that you are focusing more on whole numbers. And then a random variable that has an infinite number of outcomes with no gaps is called a continuous random variable. So an example there would be height, because somebody can be, I don't know, 67 inches tall, and then the next person could be 67.1 inches tall, and 67.2 inches tall, and 67.25 inches tall. There's no gaps. We could have all the all the different numbers to make it continuous. I hate using the word in the definition for that word, but it just makes it continuous. There's no gaps when we look at height. All right, so any questions before I move it up? I'm going to change my mind on this. I said no calculators, but you guys can use calculators. Go ahead. I want you to find the mean and the standard deviation of those 5 numbers. The mean you should be able to do pretty quickly. Standard deviation might take you a minute to remember this stuff. Anybody need a calculator? 1, 2, 3. Eric, do you need one? Anybody else? If you've already found the average and standard deviation of those top 5 numbers, go ahead and move down to the next one and figure out the kid's grade in AP Stats. You can figure out the grade, the mean. You should be able to figure out the grade, no problem. The standard deviation is a little more difficult for you. Do it. Oh. I know. Just instead of thinking about it as mean and standard deviation, if I said, Molly, you've gotten 97 out of 100 on your homework, and homework has a weight. Quizzes, you got 88 out of 100, and it's probably 3. And tests, we got 80 out of 100. What's great? Yes, but specific. Yeah. I guess that. No. Also help. We can go to those numbers.
Oh yeah.
This is the top one. I need a water. Yes, weight has everything to do with it. All right. On this top gave us the mean and standard deviation. Just as a reminder in case you forgot. Once you have it in your list, 4, 9, nope, not 6, 9, 10, 12, and 15. You go back to stat, go over to calc, choose one bar stats. I have my data in list 3. So then I hit calculate, average 10, S sub x is 4.06. On this one, I do ask you to find the mean and the standard deviation. The mean really is what the kid's grade would be in the class. And you guys should know, you've been in a grade system that weights formatives and summatives. So you should be able to figure out what the kid's grade is in the class. They just have an extra, they get to separate formative instead of putting them all together. The standard deviation, that one's a little trickier. But you guys should be able to figure out what the kid's grade is in the class.
I don't think they'll wait. I just did this deviation of 3.
Nate is going to show you guys how to figure out the kid's grade in class. You got this.
Oh, I get it.
Is it X or an asterisk being multiplied?
Yeah.
Makes me sad. You guys have always just believed that computer is right when it tells you the grade.
Yes.
No. Don't ever believe the computer.
Can't trust anyone.
No, you can't. All right.
That's kind of close.
So when you're working with grades and it's got weights, so 10% of the grade comes from homework, 30% of the grade comes from quizzes, 60% comes from tests. You change the percents to decimals and then you multiply them, and then you can add them together to get your overall grade in the class. So this kid has an 84.1. Now, there is a simpler way to do this. I just don't know if I want to tell it to you yet. No. We'll get to it later. I promise I'll tell you before we leave. But if I tell it to you now, then the formula that I'm going to teach you in a minute is going to seem pointless, which it is. But it's not, because it's on your formula sheet when you take the AP exam. So I want you to understand where it comes from instead of just thinking of it as typing stuff into a calculator. Can I flip? All right. Somebody want to read for me? Aw, thanks, Nate.
Am I reading both paragraphs?
Yeah, go ahead. And hold on. Any typos, I apologize for, because we know I suck at proofreading.
In 1952, Dr. Virginia Outgard suggested 5 criteria for measuring a baby's health at birth: skin color, heart rate, muscle tone, breathing, and response when stimulated. She developed a 0 to 1 to 2 scale to rate a newborn on each of the 5 criteria. A baby's Apgar score is the sum of the ratings on each of the 5 scales, which gives a whole number value from 0 to 10. Apgar scores are still used today to evaluate the health of newborns. What APGAR scores are typical? To find out, researchers reported the APGAR scores of over 2 million newborn babies in a single year. Imagine selecting one of these newborns at random. To find the random variable x equals the APGAR score of a randomly selected baby 1 minute after birth. The table below gives the probability distribution for x.
Thank you, sir. So we have 5 categories. You can get a score from 0 to 2. So if you get zeros in all 5 categories, you could get an overall score of 0. Or at the high end, if you get 2 in all 5 categories, the highest score is a 10. And then there's the possibilities in between. This is discrete because they only use 0, 1, or 2. They don't use decimals, so we have gaps. The probability, they looked at over 2 million newborns in a single year, and they found the probability out of those 2 million babies where they fell on the scale between 0 and 10. So first thing we're going to do is show that the probability distribution for x is legitimate. So there's 2 things that go into showing that a probability distribution is legitimate. The first one is that all probabilities live between 0 and 1. And then the other one is that when we take them and add them together, it equals 1. So the first one, there's not any work to show besides maybe just writing a little sentence that, yep, all the probabilities are between 0 and 1. Which they are, if you look at the table. I'm going to abbreviate probability and between. We don't have any probabilities less than 1. We don't have any probabilities greater than 1. So living between 0 and 1, check. That's done. Then we're going to check that they add to 1. So I'm going to check that the sum of the probabilities is equal to 1. So I'm just going to add all those probabilities together. So 0.001 plus 0.006 plus 0.007, oops, not 2 decimals, 0.008, 0.12, 0.2, 0.38, 0.99, and we see that we get 1. So they live between 0 and 1. They add to 1. So the probability distribution is legitimate. On part B, we're going to make a histogram of the probability distribution. We're going to use our calculators to remind ourselves how to make histograms. And then, of course, like I've said before, anytime you make a graph on your calculator, you make a sketch on your paper. And then we're going to describe what we see, and we use SOX. Do we all remember what SOX stands for? What are the 4 things? I was looking at you. Shape, outlier, center, spread. I was looking at you though, Michelle. You started out saying it. Maddie finished it for us, and you guys added to it. All right, so first thing that we need to do is we need to put our data into our list. So we're going to have 2 lists, excuse me. I want you guys to put the APGAR score values in list 1, and then the probabilities in list 2. And then if you remember how to make a histogram, go ahead and do it. I'll walk around, answer any questions you guys might have. I know it's been a while. we're getting some weird, that one's way too bright to even see. There we go. All right, so we're getting some weird histograms. Remember, that happens. Your data, when you put it in, sometimes it'll pick a nice window. Sometimes it doesn't. Have you pressed Zoom 9 yet?
Yeah.
You did? Okay, so Zoom 9, sometimes, remember, that'll choose a window based on the data. Sometimes it picks a good window. Anna hit Zoom 9 and it gave her that. Okay, so now we're going to go through. We're going to make sure that we can all get a histogram. And then I'm going to show you guys how to make a good window for this data. So, hopefully at this point, you at least have your data in your two lists, right? You have the APGAR scores in list 1, their probabilities in list 2. To make any type of graph from data, remember you hit second y equals. Go into plot 1. Make sure on is highlighted. Then you're going to choose the third icon for your histogram. When you do that, a lot of you, it might default the frequency to a 1. You need to change that to list 2 because list 1 is our x values, list 2 is the frequency with which they occur or their probabilities. So you want to make sure you have x is list 1, frequency is list 2, or if you put them under different numbers. Then when you hit graph, I already made a pretty window, so this is going to be our end goal, is that you all have this. But a lot of you probably have this, or something similar to it. So we're going to go in and change the window so that we can make a nice histogram. So you're going to hit window, which is up at the top in between y equals and zoom. And then it's going to ask you, well, it should have a bunch of values in there. We're going to change them to make it work for our data. So our x, remember, is those APGAR scores, and they go from 0 to 10. So I'm going to have my x-min stay at 0. I'm going to change my x max to 10 because that's the highest APGAR score. And then instead of having it x scale, means how big or how wide the bars are, instead of going by tens, I'm going to tell it to go by ones. So I'm going to see how much for 0, 1, 2, 3 separately. Y min, remember y is the probabilities, so I'm going to make my y minimum 0. I was thinking of making it a little lower just so I could actually see the bars, but I think I'll work with 0. Y max is going to be 1 because my probabilities live between 0 and 1. And then I'm going to have my y scale stay at 0.1. That's going by tens on the hash marks. So you should have those numbers in there. Don't mess with x resolution or delta x or trace step. Don't mess with those numbers. Everybody good? Now when you hit graph, it should look like this. Any questions? Anybody not have? Anna? Oh, you know what I did wrong? Sorry. I was thinking about, because you have your last bar is higher than the previous one. And so, which makes sense, it's getting higher, getting higher, getting higher, and then it drops lower. If I hit trace, from 0 to 1, I have 0.001. And then if I go all the way over here, that's from 9 to less than 10. So I have 0.437. So I don't actually have this last bar. I only have 10 bars in there, and there are 11 things. So I forgot. Go back to your window. We want to make that X max 11. And then it should have that last bar drop off.
What plot do you have selected in the stat plots?
The histogram, the third one. That one.
Oh, okay. There we go.
All right. Are we good now? Any other questions? No. All right. So I'm just going to make a quick sketch, and then I'm going to have you guys do your socks off to the side. So we have, here's our y-axis, x-axis. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this has got 0.5 and 1. And then we're just going to make a quick sketch. This first bar barely gets off that x-axis. Same with the next one. There's such small probabilities, they don't do much. They stay pretty low for quite a while until we get to 7. And then it actually has more of a bar. And mine is not perfectly to scale, that's why it's a sketch. But it looks something like that. I don't know why this one looks higher than that one. I didn't purposely do that. I apologize. So we want to describe what we see. So the first S is shape. What is the shape of our graph? Alex, I heard what you said. Skewed to the left. I'm going to say slightly skewed left just to have my safety word in there. Oops, sorry. There we go. Outliers. Possibly on which side? On the left, the low side. Since we have skewness to the left, it's most likely we have outliers on the left or the low side. Center. How would we find the center? What do all the probabilities add to? They add to 1. What's in the middle of 1? 0.5. So we need to figure out which bar all the probabilities have added to 0.5. Now, since we start with really small probabilities, I'm going to work backwards because I'm probably going to get to 0.5 with these numbers quicker than adding all these numbers together. So 10, an APGAR score of 10 has a probability of 0.053. 9 has 0.437. That's 0.49. So that means that I have 0.51 and 8 and below. So my center has got to be at 8, right? That would be where I would get 0.5. Did I make sense? Yes, no, maybe so. I don't know why I made my 8 like that. I never make my 8s like that. And then spread. We're looking at the probabilities. So our spread goes from the smallest is 0.001 to the largest is 0.437. Any questions before we look at part C? I thought about writing that, putting that the probabilities range is 0.436. I'd accept either one, stating the actual range or giving me the value of the range. Any other questions? All right, part C says that doctors decided the APGAR scores of 7 or higher indicate a healthy baby. What's the probability that a randomly selected baby is healthy? So in math notation, we want to find the probability that X is greater than or equal to 7. So for the probability that X is greater than or equal to 7, we're going to take the probability that it's equal to 7, and we're going to add all the probabilities that it's greater than 7. So we're going to end up adding those 4 numbers together, and that'll give us the probability of X being greater than or equal to 7. So we get, when we add them together, we get 0.908. Any questions before we move on? All right, so down below, we're going to find the mean or expected value for our discrete variable. So first I'm going to show you how they get the formula. Like I said, this formula is on the formula sheet, so I want you to understand where it comes from. Then I'll eventually show you the shortcut. But I want you to know when you see a formula on the formula sheet what it means, so you're not like, oh, she never taught us that. So if we're working with a discrete variable, x, and we have this distribution right here. So here's our probability distribution of x. Now this is just a general distribution. That's why we use variables instead of actual numbers. So to find the mean, we multiply each possible value by its probability and add them all together. That's like Nate showed us back here to figure out the kid's grade in AP Stats. We took the score times the percent, the weight in class that makes up the grade, and then he added them all together to figure out the kid's grade. So that's what we do here. We would take this value of x, x sub 1, and multiply it by its probability, p sub 1, and then we would add it to those two being multiplied, add it to those two being multiplied, add it to those two being multiplied, so that we can find the mean of x. So we would have x sub 1 times its probability plus x sub 2 times its probability. And I'm going to skip 3, otherwise my handwriting's not going to fit. And then we'd have x sub k multiplied by its probability. And we add them all together. Rather than writing out all of those things added together, we have our summation notation. So we use the capital sigma. And then we would have our x values, and they use I, means indices, the index. So all the x values times their probabilities, and then we add them all together. Now, sometimes you'll see this with mu sub x, meaning it's the mean of x. Sometimes they call it expected value, and they put E of x. This is read as expected value of x. So like I said earlier, if it says find the expected value, it's asking you to find the mean. If it says find the mean, it's the same thing as asking you to find the expected value. I don't know why in math we get used to one term and then we decide to call it something else. I would say that's my least favorite thing about this subject. We suddenly will change names on you. And just in case, I know we've used that symbol before, but it does mean sum. So this is the formula that you would see. This right here is what's on the formula sheet. So we're going to find the expected value, or the mean, for our APGAR scores. And then, of course, just like many other chapters, we have to be able to interpret our answers in the context of the problem. So first we're going to get the mean, the expected value. Then we're going to write a sentence to explain what it means. I'm going to make you do this by hand first, then I'll show you the shortcut. So we're going to find the expected value, I'm going to use a different color, of x, also known as the mean of x. So we're going to take the value, multiply it by its probability, then add it to the next value multiplied by its probability, all the way through until we've done an APGAR score of 10. hopefully my calculator doesn't get in the way. So our first APGAR score is 0 times its probability plus 1 times its probability. Oops, forgot to close my parentheses. Alright, hopefully I didn't miss any other parentheses, otherwise I'm going to be really screwed up. So we get an expected value or a mean of 8.128. And then last thing, we're going to interpret what that means in context. So we would say something like an APGAR score of 8.128 is typical. Meaning a randomly chosen baby would be considered healthy. Randomly chosen baby would be considered healthy. Sorry, I apologize for the handwriting. I haven't written nearly as much in 2 weeks. I know it's really sloppy. Questions before I flip it over? Right. So now we're going to look at the standard deviation formula. Again, I'm going to show it to you, and then I'll show you the shortcut. So we have the same general probability distribution where we have variables instead of numbers. In this formula, when we use mu, that's going to represent the mean of x. So when I use that symbol, it's the expected value. The variance of x is sigma sub x squared. Standard deviation, remember, is your variance, the square root of your variance. So you might want to make note up at the top. So to find the variance, we would take each value of x, find out how far away from the mean it is, and then we would square it, multiply it by its probability, and added to the next value, subtracted from the mean, squared, multiplied by its probability. So we would have our first value of x minus the mean of x squared multiplied by its probability plus the next value of x minus the mean squared times its probability until we got excuse me, through the whole list. Oops, forgot my square. Rather than write it out like that, we use the summation notation. So it would be the sum of the x's minus the mean squared times their probabilities. Standard deviation is the square root of the variance. Now, for some reason, they don't give it as a standard deviation formula. This is the formula you would see on the formula sheet. You would need to know that to get the standard deviation, because that's what they would ask for, you would have to square root. I like to write it, but they don't give it on the formula sheet. We would just square root both sides, so the square goes away there. So we have sigma sub x, and we're taking the square root of the sum of the x's minus the mean squared times their probabilities. But like I said, for some reason, they give it as the variance, not the standard deviation. So if we were to find the standard deviation of the APGAR scores, we would do something like sigma sub x is equal to the square root, and it's going to be a lot of things added together, so I made my square root really long. We're going to take 0 minus the mean, which we found on the previous page was 8.128. We're going to square that, square it, and then multiply by the probability of getting an APGAR score of 0 plus the next value, 1 minus the mean squared times its probability. And since I'm going to show you the shortcut, I'm going to skip right to 10 with my little ellipse thing. Except for I talked and messed up what I wanted to write. Squared and you could do it by hand, but the calculator does it for us. So that's where I'm going to show you guys the shortcut really quick. So you should still have the APGAR scores in list 1, their probabilities in list 2. So you want to hit stat, and we're going to go over to calc, and we're going to choose 1 bar stats, which seems a little odd because we do have 2 lists. Make sure that list says list 1, whatever the values you're looking at. Their frequency, so the frequency list is their probabilities, or list 2. And then we're going to calculate. And the very first one the average. I just did that on the previous page by hand. We got 8.128. And then our standard deviation is the sigma x, which is 1.437. So we don't actually have to do them by hand, which is nice because doing that in your calculator would take forever. But I did want to show you guys where those formulas come from, because like I said, that's what you'll see on the formula sheet. So once you have your lists, you go stat, calc, 1-bar stats, and you want list to be list 1 or whatever list you have the actual values in, and then frequency list is your list of probabilities. And then x bar is your expected value of x or your mean of x, and sigma x is your standard deviation. And I almost forgot. We need to look at how to interpret standard deviation in context. So our standard deviation is 1.437. So on this one, let's go 1.437. So when we interpret standard deviation, what does standard deviation tell us again? Anybody remember? I think somebody said something that I didn't quite hear. Standard deviation tells you how far away you are from the mean on average. So we would just say something like, on average, I'm going to abbreviate average. APGAR scores vary from the mean. By 1.437 points. Questions? Okay, we're gonna do the bottom one. See a lot of you wanting to pack up. This is just what we did, but shorter. I took a lot longer to explain it. Show that the probability distribution is legitimate. Compute and interpret your mean or expected value. Compute and interpret standard deviation. It shouldn't take too long because the calculator does most of it for you. But I do want you guys to try this before we pack up. that's the average. I mean, yeah, you don't.
1.1 car.
Yeah, but it's for what? A month or Friday? Isn't it?
And each hour.
So you would say on average, they looked at Friday. For randomly chosen Friday, the amount of cars sold per hour.
1.1. They just sell for the car.
Well, no, they don't.
Oh, I know. But it's on.
It does sound weird. I get what you're saying. I don't know. That's 0. That's 0.4. That's 0.4. And that's 0.3. And 0.4 plus 0.4 is 0.8 plus 0.3 is 1.1. 0 times that is 0. 1 times 0.4 is 0.4. 2 times 0.2 is 0.4. And 3 times 0.1 is 0.4. So 0.4 plus 0.4 plus 0.3 is just 1.1. Yeah. Yeah, you're out of Will you go to that
Go.
I'm running out of time. Alright, Zach's putting up the answers for us since we're running out of time. I'm looking at Maddie. Between you two, I wasn't looking at you really. She's like, okay, look. Maddie and I were giving each other, I don't know what to say. Really looking at each other. We weren't really doing eyebrows, we were doing more wide eyes, head tilts. Thanks, sir. Alright, so all your probabilities are between 0 and 1. When you add them together, you get 1. Average is 1.1, or the expected value of x is 1.1. Standard deviation is 0.943. Your interpretations might be slightly different, but they should be similar. Any questions? Remember, homework is these 5 problems. I will have your outline for you next class, and hopefully I will get your unit practice in this afternoon if I run home. If not, tomorrow. I do apologize, I left them at home like a doofus. I can't believe I did that.